Assalamu alaikum, dear student. This is Wajid Ali Shah. Today we are going to explain and discuss Gauss's law, which is given on page number 21st in textbook board Peshawar. Gauss's law. In introduction, we will start with the introduction of Gauss's law. In previous topics, we have discussed Coulomb's law, which provides a method of calculating electric field intensity. But sometimes that becomes much more complex and difficult to find electric field intensity by the use of Coulomb's law. Anyhow, we have another law by the name Gauss's law, which provides a simple technique of calculating electric field intensity for a charge distribution. The statement of Gauss's law is the total flux through a closed surface is equal to the charge enclosed by that surface divided by the permittivity of free space epsilon naught. Mathematically, we can write Gauss's law as the total flux is equal to total charge enclosed by the surface divided by epsilon naught. This is mathematical form of the Gauss's law. Now, derivation for Gauss's law. For the derivation of the mathematical form of Gauss's law, let us we consider a closed surface like a sphere which encloses any charge q at its center. In order to derive an expression for Gauss's law, let us consider a closed spherical surface enclosing a charge q at its center. According to the technique, for simplicity, let us divide this whole sphere into small patches, which I had already called differential areas. And the area of each page is delta A1, delta A2, delta A3, and so on, delta AN. This is a simple technique to divide the whole surface area of the sphere into small patches of small areas. Now, as the charge is enclosed by this spherical surface, electric flux of this charge will be passing through each page of the small area delta A1, delta 2, delta 3, and so on. Similarly, electric field intensity of this charge which is coming out of the sphere through every unit page, unit area, small differential area, electric field intensity 1, electric field intensity E2, electric field intensity E3, and so on. Electric field intensity En. Similarly, we can find the flux passing through this delta A1 by the equation of the flux, like phi 1 is equal to E1 dot delta A1. We can also write the above equation like this. Phi 1 is equal to E1 delta A1 into cos of theta 1. Where theta 1 is basically the angle between the area delta A1 and electric field intensity E1, like in this case. This is area delta A1 and this is electric field intensity coming out of the spherical surface. The angle between these two directions is theta 1, which is numerically equal to 0 because of the same direction. So we can put the value of theta 1 like E1 delta A1 cos of 0. And in trigonometry we know that cos of 0 is always equal to 1, so we can finally write E1 delta A1 for this small flux. Similarly, flux 2 E2 delta A2 cos of theta 2. This theta 2 is the angle between the direction of this area and the direction of electric field. Again, they are having same direction, so we can write theta 2 is equal to 0. And finally, we can have E2 delta A2. Because cos of 0 will be equal to 1, and we can write it like this simply. Similarly, and so on. Flux N, En delta An cos of theta into n. Again, theta n is again equal to 0 because the direction of electric field intensity for nth part of area and for nth part of electric field intensity will be 0. So we can write En delta An. These are individual small fluxes for individual small areas. Now, as we know that flux is a scalar quantity, so adding all the individual small fluxes in order to get the bigger the capital flux, like phi 1 plus phi 2 plus phi 3 and so on, phi n. This will be giving us maximum flux of the total sphere which is enclosing the charge q. So putting the value for phi 1, phi 2, phi 3 and so on, these values, A1 delta A1 plus E2 delta A2 plus similarly E3 delta A3 and so on, En delta An. This is total flux. We can write it like phi t. As we know that geometrically the sphere is having the surface of the sphere, each part of the sphere, each individual page of the sphere is having equal distance from the center as it is a geometrical sphere. So electric field intensity through each sphere will be same. We can write E1 is equal to E2 is equal to E3 is equal to En is equal to E. Electric field intensity is constant throughout these small patches of these small areas. We can put this E instead of E1, E2, E3 in the above equation, and we can write total flux is equal to E. As E is common, so we can take it outside as a common. So finally, this equation becomes A1 plus delta A2 plus delta AN. So I hope, students, that you will get this, that E into, by adding up again the small areas of the sphere, we can write sum of all the individual areas. I is equal to 1 up to NAI. Or simply I can write for spherical surface, we can have this total sum of the area is equal to 4 pi r square. So finally we have that the total flux is again given by phi is equal to E into 4 pi r square. From our previous knowledge, we know that E is equal to 1 over 4 pi epsilon naught Q divided by r square. This is the value of E, which we already had derived in previous videos, previous lectures. This is the value of E, this one. And now putting this value 4 pi r square, which is the total surface area of the sphere. So cancelling, we have some cancellation here, 4 pi and r square with r square. So this part of the equation is cancelled, and finally we have the total charge Q enclosed by the surface divided by permittivity of the free space epsilon naught, and this is the mathematical form of Gauss's law. Gauss's law basically shows that the total flux of the charge enclosed by the surface is directly proportional to the total charge enclosed by the surface. Total flux is directly proportional to the total charge enclosed by the surface. Another part is total flux is inversely proportional to epsilon naught, which is the permittivity of the free space. These are two relations combined in Gauss's law. The third important point is that flux does not depend upon shape, size and geometry of the closed surface. Thank you, and that's all. If you have any question, any problems, so you can follow the link in your WhatsApp groups. This video will be uploaded on YouTube, and you can ask any question related to Gauss's law. Thank you, and that's all.